So in this one here, we're asked to calculate the product for each pair of complex numbers whose imaginary parts have opposite signs. Those numbers are called complex conjugates. So for example, you see that if we have, 2 plus I, then we also have 2 minus I as one of our roots. The reason for that is because remember, anytime that we take the square root of something, we get the positive or negative value. So when we see I, that's the square root of -1. So we get that plus or minus possibility. So just like when I'm telling you that, like, hey, my graph crosses at 3. So in the equation, I have this x minus 3 because that's what gives us our equation, or this number would make the whole equation 0. That's what defines roots. I'm going to do the same thing with this 2 plus I and 2 minus I, right? 2 minus 2 plus I and x minus 2 minus I. I'm going to distribute that negative here. That's plus. And now I have this product of what we're looking for here to multiply. So if I were going to multiply this together, I'm going to go ahead and use the box method, but I'm going to, instead of using just 2 by 2, it's 3 by 3 here. So now I'm going to go through and do this, negative xi. If I do this correctly, it should get rid of any of my I values here. So negative 2i and 2i, and then negative I squared. So what I want to show you here is that negative xi plus positive xi is 0. Negative 2i plus 2i is also 0. And so really I'm just going to be adding together these things because I squared is equal to the square root of -1 squared, which is just -1. So really what I get here is x squared minus 4x plus 4x plus 1, because negative times a negative is a positive. So I get x squared minus 4x plus 5 as part of that equation. For b here, same idea. I'm going to go ahead and take, the x minus 3 minus 5i, x minus 3 plus 5i. Again, I could put it in parentheses like this one here and distribute, but what I end up getting is still kind of the same thing here with the minus and then the plus. So now I'm going to go ahead and throw it in a box, and we are going to see what we get here. So once I plug that into the box and I get rid of anything that cancels out, add everything together, and remember this minus 25 I squared changes to plus 25 because I squared is -1. So for C, what complex number can you multiply 3 plus 2i by to get a real number? And we can multiply it by its conjugate, or its complex conjugate, of 3 minus 2i. What is the complex conjugate of a plus bi? That would be a minus bi. And what happens when you multiply any complex number by its conjugate? Well, it becomes not so complex anymore, basically. It'll become a real number.